Geometry lesson 1-4. Beginning with here, we're going to kind of get into some angles. For angle, the actual definition of an angle, just so we're all on the same page, two different rays. Now remember, a ray has a starting point, and then it continues on through another point forever. So here's the same starting point, but going to a different ending point through that forever. Two different rays with the same initial meaning starting, point, known as a vertex. And then the rays continue on from there. Each of those rays will create what we call sides. So every angle has two sides, and those sides are the rays that share a common endpoint known as a vertex. Making sure everybody knows about what we're talking about. All right, a protractor postulate. Now remember, a postulate is something that we take as being accepted as fact without any proof. Each ray of an angle is going to match up on a protractor. So each of the rays matches up with a protractor. That's how we determine the space in between it. So the first thing you want to do is on the 0 degree or the 180 degree line, you're going to put one of the rays. After that, you see where the other ray lines up and the absolute value of the difference. Very similar to the ruler postulate. It doesn't matter if you take 120 degrees and subtract 30 degrees, you're going to get 90. If you take 30 and subtract 120, you're going to get negative 90. But the absolute value of that difference produces the same 90-degree angle. All right? We also look at angles in between these two rays, or in this angle, with this dot right here would be considered an interior point, because it's between the two rays. Anything outside those two rays, here, 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 would be considered an exterior point. So there's interior paint that's used for the inside of your home, and this exterior paint, which is used for the outside of your home. Interior, exterior. Now, as far as the protractor is concerned, here I have an actual protractor that the smartboard allows me to manipulate. This line across the bottom is what we call the 0 or the 180 degree line. Right now it's actually saying 0. And if I were to move this up, this protractor is pretty nice because it tells me what the angle is where I've left it. You'll notice on all protractors there's two sets of numbers. One of the numbers starts at 180 and the other one starts at 0. Well, from here 180 to 170, I'm not going to say that that's a 170 degree angle. If it's only gone up a little bit, that would be the 10. So I'd actually want to be counting from 0 all the way up using this scale. If I was starting on the other side, which is possible, then I would be starting at 0 and I'd be going up on the outside of the scale. So it depends on which side I'm at. According to what I mentioned before, you would want to match this particular scale up so that the vertex is in the middle of your protractor. And then one of the lines, one of the rays of the angle must match up on that 0, 180 line. From there I can move it so that it matches up with the other ray. And that is telling me that that's a 36 degree angle in between those two rays. So if I move the protractor, you can see that that angle is the same as that angle, and that's how we measure it to be 36. Now this particular, so 36 degrees would be this angle here. If I take the protractor and I move it down here, it doesn't match up very good how it is, so I might need to rotate it. And I can pick, it doesn't matter which one, but one of these angles, one of the rays, needs to have the vertex, and it needs to match up on the 0, 180. So there I've matched it up, and then I draw this out until it matches up, and according to that, that's an 85 degree angle. So that's my measurement for the angle. That's how I describe it, and I put 85 degrees on there. And that's how you want to use a protractor. Obviously the protractors you use are plastic and clear, and you're not actually moving anything. Some of them do have that moving part, but typically you just line up the lines and then you make a mark to yourself of where it would be. Alright? Angle addition postulate. We had a segment addition postulate that said if you take one segment and add it to the other, it creates the whole thing. It's very similar for an angle addition postulate. If we take this angle and we add it to this angle, it's going to produce the entire angle. This is the symbol for angle, and the reason I have 3 letters is because it gives me a starting point, a middle, and a finish. So if I start at R, next it tells me to go to S, and I finish at P, then angle RSP is this point right here. I don't want to say angle S, because if I say angle S, Am I talking about this one? Am I talking about this one? Am I talking about that one? There's 3 possible angles that are all involving S. So I need to be more descriptive, and that's why we use 3 points. R, S, P. Next is TSP, starting at T, going to S, and finishing at P. That's this blue angle. So together, it would be RST, R to S to T. That angle plus this angle makes the giant angle here. Alright? Now, I've labeled this as TSP, TSP. That's no different than angle PST. Same thing. It has the same middle value. But I would not want to say angle SPT, because that's actually this, which is totally different. So the order matters so that I have the same middle value. But it's very similar to the angle addition postulate. The segment addition postulate. If I said this was a 30-degree angle and this was a 50-degree angle, then the total is going to be 80 degrees. So numerically it matches up. Some things that you've already seen in your past, but we want to make sure. An acute angle is any angle that's less than 90. A right angle is when the angle is exactly 90 degrees, and we use that symbol of a square inside there to represent 90. And we have obtuse. An obtuse angle is anything that is greater than 90, but at the same time, less than 180 degrees. And a straight angle is when it's exactly 180 degrees. Now you might say, well, this looks like a straight line or line segment. True, but it is 2 rays. There's a middle here, shared vertex, a ray going this way and a ray going this way. It just happens to be that it's 180 degrees. Alright, and lastly in dealing with these angles, we have what we call adjacent angles. Now adjacent is kind of next to. 2 angles, you may not see them here, but I've got one green with the red line, and then this green with the red line. 2 angles that share a common vertex. Here's our common vertex. And they share one side, which I've gone ahead and made it red. But they have no common interior points. So this is one angle here, and this is one angle here. Anything that's an interior point for this is not an interior point for this. So you must be careful about that. Here's a common mistake that somebody might look at. They'd say, oh, so would this be considered adjacent angles if it shares this line here and goes down there? So saying that angle and that angle. This would not work. This is the shared line now. So there's one angle here. The reason it doesn't work is because any interior angle for this, or any interior point for this angle, is also an interior point for the other one. So they're sharing, it's overlapped, and that is not going to fit this definition. No common interior points. That's why this one works. The interior points for this are different than the interior points for that. They share a side that's kind of in the middle or in between. It doesn't have to be in the middle. But this one here would not work because it's sharing those interior points. Some of the interior points for the whole are also in the one that's in the middle.